don't
there's
know.
so many little ones.
Sorry,
Right? Yeah.
sorry, Julie, can you ask that question one more time?
How do the plumose anemones reproduce?
I think those was probably reproduced by broadcasting eggs and sperm, and so they probably then meet and settle. So I think someone was saying they had lots of little ones
Yes.
around. So yeah, they probably bred in the tank.
Oh, okay.
Other kinds of anemones, like the really common intertidal green anemone, Anthoplura elegantissima, they can reproduce by splitting. So they can, a whole one can then kind of split into two. Other ones like Epiactis, the little strawberry anemone, they bud off little ones all around the base. So you have one that's got these little ones all around the base of it. They look really kind of cute. And they can also move around a little too. Like people don't realize that if you ever take if ever one of the anemones is stuck on the glass of the tank, it's neat to take a wax marker or a pen and just draw around the base and then see if it's in the same place tomorrow.
Oh.
And like they look like they're stuck on, but they've got they can sort of slide slowly on that disc that they have on the base, so that over the course of several days they can reposition, they can move around if they feel that they want to get a better taste of the water currents or whatever.
Would that be acceptable if we decided to put little bits and pieces on the?
Yeah, why not? Just
Removable.
Yeah, exactly. As long as it's removable, but maybe draw around it and see if it's moved in a couple of days. If it's not doing it, then you can maybe then wipe it off. But I think those Metridium, those plumose anemones, I think they do move around a bit. I remember a friend looking at that was.
We have window markers that are easy to.
Yeah.
Pardon me?
We have window markers that are easy to. Yeah.
Yeah.
Can you put one in the cart?
Yeah.
Like those whiteboard markers.
Thank you.
Yeah.
The other thing I'll talk about in here is the lab. It's small, but it's well equipped. We use it for our day-to-day of identifying specimens, of working with things like the alcohol. We have extractor fans that can handle with any fumes. It's also where we have a lot of our lab supplies, field gear supplies, and where we have our catalog books. And I'll show you those. Just a sec. So here's an example of, we have that, I told you we have that, the online database. And that only came into being, I don't know, 5-10 years ago. How it all started and how it continues today is with actual catalog records, catalog books. So this is the record for 1977, and this has every specimen that was registered in 1977. Just find a couple of examples. So this one is, it starts with 97796, so it was registered 977. It was the 96th collection event, and they collected.
Throughout the whole institution, or just at this collection? No, but throughout the whole institution, the 96 or just the invertebrates?
It was the 96th invertebrate collection of that year. And there are 7 lots attached to it. And there's all the information as well. So it was Davidson Bay, North Pender Island, collected by Phil Lambert. It's high tide, the habitat was mud, used scuba to collect. And then every distinct thing he collected goes in here as a distinct line. So there's, Modiolus rectus. Modiolus rectus is it's a mussel. It's just a type of mussel. So in there, each one gets a distinct, this is the first, second, third, and then that all together forms its unique catalog number. So this one, that Modiolus, is 977961, and it shall always be. And it's also, we'll note that if there were some if someone, even this year, like if someone gave me a specimen this year that they collected in 1977, I would actually put that in this year's book, not the 1970s. It's not when it was collected, it's when it's entered into the museum's collections.
I take it the filing system is universal across museums?
No, everyone does something slightly different. everyone has different. Some of them, so this system of doing by each collection event is fairly handy. But I've been to other museums where they have, like, all their old stuff is in these big, old ledger books, and they open up, and every specimen, and it just goes in one by one. It's not distinct events, so it's just written in, one by one by one.
Actually, I take my question back. It's too much to ask.
Yeah,
You think about the localization.
And most museums, started before. I mean, this is like in the 1700s or the 1800s, or they came out of private. So they all developed their own solutions before there was any kind of real organization or around museums or between museums. So nowadays, several places have, maybe they use the same software to do their databases, but they've all got their own unique style of how they do their numbers.
But even categorizations are constantly changing within
Exactly.
natural history, never mind just one area.
Exactly, yeah. So and that's a job too, where if I go through and if I had a look at this species, and if the name of this species just happened to change because of a paper, we wouldn't change that.
No.
But if I went through and I looked at that specimen and re-identified it as something different, then I would cross that name off. So I have to go back, find the original book, cross it off, and and update the name, because that's what I would do. I do that in the database as well. I said I work on bivalves or clams. So I usually spend Fridays as sort of a reward. I go through the unidentified bivalves in the collection, and so they have collection information. They're registered, but all they have is bivalve on them. So I take that and I put a name on them, and then I have to go back into the books and see, it maybe you had just bivalve twice, cross it off, update it in the database, make a new label for it, put the new label in the jar, put it on the right place on the shelf now. So it doesn't just sit, they're all at the beginning of the bivalve section, just a big miscellaneous bin. So I do that so it can go onto its proper place.
Because whoever accessioned it didn't know what the species was?
They didn't know what it was, or they didn't have time to fully identify it, or there's lots of stuff that, for best of intentions, just you don't get around to it, or didn't get worked up all the way, and it's easier to put it on the shelf like that and get someone else to upgrade it fully the rest of the way.
Right.
So going back to the thought I had before, you talked about one species then being identified as two separate ones, depending on location. And I thought, what makes a species? But now listening to this, it sounds very likely that different museums have the same animal identified as two different species.
Oh, absolutely.
Or
yeah. So
it's not
there
it's
have
entirely
been
possible. It sounds like.
And that's why research that goes on here, or the kind of research we do in taxonomy, requires a lot of homework, and it's slow and steady, and you have to be diligent. So what you do is you find a lot of different papers that have it. You track down as many specimens as you can. You see as many specimens as you can. You see similar specimens or similar species to see if there's misidentifications. So you want to really cover as wide a sample as possible, to make sure you're finding all available specimens. We tend to try and use some standardization now. There are some really good websites like the World Register of Marine Species, which is a collaborative website that tracks species names. So I could go look up that Modiolus rectus, and it would have its name, Modiolus rectus, who described it, and any possible synonyms that other species that had been named that, or that were then synonymized with that species, or if it was originally given, if maybe it was Mytilus rectus and then someone changed it to Modiolus rectus. These are all kind of complicated history of just the name of those things that are really important to know. And before things like this were around, all you had to go on was reprints and your library. And if you didn't have the right paper or didn't have, I can't imagine how people did it in the past. It was really difficult to keep track of the names of things or what changes have happened when.
So what makes a species? Does it get down to DNA?
Sometimes. That gets really difficult, and there's still no great answer for that. For a while, we had really easy answers, like, oh, they can't interbreed, or they look different. But there are
so
more and more.
Partly life cycle, partly.
Yes.
Anything else.
It also even matters of what are you trying to do? Like if you're doing some broad ecological things, then you can be fairly broad with these things are basically the same. They do basically the same thing. Like you could identify down to a certain level and be happy with that. They're functionally the same. But if we get into the real nitty-gritty of something, well then how many populations, is each distinct population of a species a distinct species? And we're finding lots and lots of examples of things that look identical, but they're genetically distinct. But how distinct does it have to be before you call it, a new species? And that's, there's a lot of debate over what constitutes that. Usually when you're describing a species, you provide some justification either on the basis of genes, DNA, or the morphology, or are they? Another good example is if you collect a bunch of them, say all across BC, and you do the DNA and you find okay, they do separate out, and then you map them, and okay, if they tend to fall into distinct areas, then that's a good there's a good sign that they're fairly they're distinct, and you could probably call them two separate species. But yes, you're asking me difficult questions. That's a good question.
We don't get that kind of question.
No.
Time.
Well, sometimes that does happen. You get a lot of naive questions that are often the most difficult ones. I mean, kids or people don't and they don't know what's not a good question or not, so they ask stuff that can be very difficult. Like, how do you know what's a species? And you go, that's an excellent question. Or they don't realize how fundamental a question that is, because someone.
The reverse thing is true too. We probably have at least 4 different species of sea cucumbers in that tank at one time. They do not look alike at all.
Yes.
Basically.
Yeah. Or sometimes you have something that's the same species that looks different. I mean, those Paisaster have different color morphs. There are blue, and there are orange, and there are purple, and so. And that's part of what we do here as well. Part of taxonomy is the first person who came across something, and sees it as distinct, finds it and names it as a new species, and someone else finds one and they name it as a new one, and someone eventually has to go and sort of take a look at a bunch of them and go, I think they're similar enough, and do that kind of review. So that's another reason why the kind of work we do here is not really done in university, because it's long term. It's not just in terms of its scope, but the time it takes. It's diligent. You have to collect a lot of specimens, look at a lot of specimens. It might take years to get a review of a single species, and that'll result in one paper that no one else will ever cite. But that is really important to have, because you have to know what a given species is. So it's work that's really important, and I think unfortunately it's a little undervalued, or it's a lot undervalued, and because people need to know how fundamental it is to know what life on Earth is, and that comes down to knowing exactly what species we have at any given place, and that means you have to have someone who has the skills to identify it or put it into its proper context. And so one of the things I was going to show you as well is I set up on some of these microscopes around here. I have a couple specimens. If you haven't had the chance to do some of this before, we're not going to key them out, but I wanted to show you some of what we do and the kind of information we do. You may see some you see guidebooks, and they're good. They've got little descriptions and they've got nice big pictures, but the real nitty-gritty when it comes to actually identifying specimens is in much larger book. Can you pass me that larger book there?
This one?
Yes. This is a great book. This is Eugene Kozlov's Key to Marine Invertebrates in the Pacific Northwest. So it's following what we call a dichotomous key, which is you're going through. It's a I use the analogy, it's like a choose your own adventure story, because you start here and you have a choice to make. Does your specimen have 12 pairs of, whatever, or does it have 15 pairs of elytra? If no, turn to number 3, and you go down through the list, and you basically, it gives you a choice of 2 things. That's why that's the dichotomous part. It gives you a choice, and based on the specimen you're looking at, you say, is it this or is it this? Okay, I'll go there. And you move down and down and down and down and down. And what you're doing is you're eliminating other things, other branches, other possibilities. Because if all you had was a full description of every species, you'd have quite a lot, a full description of something is several paragraphs, because it's describing everything from the eyes to the antennae to the spines and many of them are very similar and they only differ by one thing. So how are you going to pick up the one detail there? So that's another thing we sometimes use when we talk about species is its description would be that the description is everything about it, and the diagnosis is what is the distinctive character of that species. So when you describe a species, you give a full description of everything, all the details, and then its diagnostic features are what sets that apart. It looks, it has all the other wormy characters of that family, except it has 4 spines on its nose or on its head instead of 2. So that is the diagnostic feature. So and that would be one of the characters that you'd use in the Keo you'd come across. Eventually, it's like, does it have 4 spines or 2? And you go, okay, 4. We'll move to number 27, and then it gives you a name. Okay, yeah, that's that one.
Is it pretty clear if it was ripped off just because of something that happened within its life? Like it actually started off with 15, but now it has 13 because...
Not always, because a lot of this assumes you have a mature, adult, intact specimen, and there's a lot of things that if you don't have an intact specimen or if it's juvenile, you can't really identify it. There's not much hope of, because we don't know well enough what these animals are like through their whole history. If someone wants to go through and look at all the juvenile, take every one of these scale worms and look at it as it develops, and as it's a juvenile, and see how they all differ from each other, then that's a great project. But we don't know. So yes, that's a big part of it as well. We can only really look at the best of the specimens, or I put names on them. So what I've got on some of these here is I'm not going to ask you to identify any of the specimens. They've got names on them anyhow. That's fine. But I thought I would just put some things under the microscope for you to look at, because that's something people don't have a chance to do that often as well. You see things up close, and you see things that you can hold in your hands. Here's a gumboot kite. Here's a Pacific sea star, or here's a red rock crab, and here's how they're sort of distinct. And people have these very sort of set ideas about these very distinctive things that make up something. It's easy to see, well, this big crab, this big thing. But there's a lot of other things they don't appreciate exactly how much detail there is. So especially little things like, I'll show you there's a worm there, or a little brittle star. You might see a brittle star in your palm, and you see it's got a little disc and it's got these kind of wavy arms. But if you look really closely, you actually see each of those arms is made up of hundreds of little segments that look like human vertebrae, and they've got spines that come off of them. When you flip it over, and it's got 5 teeth in the mouth, and then little pockets where the arms insert around that's where the water flows in, and they use as used for respiration. Or that the entire disc, which looks solid, is actually a mosaic of other smaller calcareous pieces that are held together. So just to appreciate that there's so much fine detail, and how someone can spend their entire life studying nothing but brittle stars, or just looking at brittle stars under a microscope. Exactly. So I want people to see that, because they don't realize how much detail there is. Like, how are there whole books full of written about worms or about brittle stars or whatever? Have a look and see the amount of detail. And the easiest thing to do that with is to show people something under a microscope, and they look at something and go, "Wow, I didn't realize there's all that detail there, or there's so much going on in just this little thing." So that's what we're going to do, and I just have a couple of some books by them next to each one that has a couple sort of open to the relevant page. You'll see what you're looking at, and you'll see how it's expressed in the book, and the kind of words that are written about it, all the detail, the diagnostic characters about it. So I've only got 3 microscopes, unfortunately. There, and there. But if you want to kind of, we'll take turns at different microscopes, and we'll have a little look at things. Is
Yeah,
that okay?
work in fours.
Yeah, something like that. So